You know, we use the word system to describe something that is made up of different parts that must work together in order for the system to function. A car, it's a mechanical system, and it's made up of different parts, like an engine, the body, the doors, and the wheels. Each part can't get you where you want to go, but when the parts work together as a mechanical system, you can go places with it. The International Space Station is also a mechanical system, with parts in it that work together as a whole. Say, do you know how busy the astronauts are on board the International Space Station? Well, let me tell you, each astronaut conducts hundreds of experiments for scientists in the United States and in many other countries, so they could use a little help. Now, let's go to NASA Ames Research Center and meet engineer Yuri Gaudiak, who thought of a way to help the astronauts. Yuri, tell us about how you're going to help the astronauts on station.
Well, in addition to doing experiments, the astronauts have to do a lot of logistics, inventory tracking, air samples, and water samples. So as a research team, we wanted to help offload those activities. So we developed a robot that we were inspired by Star Trek with the tricorder and by Star Wars with a floating orb. And what we added to that was the ability to do scheduling, procedures, training, and then also environmental sensing. And we wanted it to be mobile so it could go follow the crew or go off on its own and actually monitor by itself. So what we developed is the personal satellite assistant.
Yuri, that is so cool. You know, let's find out more about this robot that NASA is building to help the astronauts. As you watch the program, think about your robot as a system and the parts it will need in order to perform the tasks you assign to it. Now guys, this is the PSA, or Personal Satellite Assistant Laboratory here at the NASA Ames Research Center. And this is Dr. Keith Nicewarner.
Hi.
How are you, Keith?
Good.
Tell us, what will the PSA be able to do?
Well, the PSA will be able to check the inventory, the temperature, the air pressure, and air composition on the space station. It needs to move around by itself in microgravity, avoid things that get in its way, and communicate with computers and people like mission control and astronauts. It must also understand the astronauts' commands and let the astronauts know when something needs to be addressed.
So Keith, it sounds like the PSA is a system that's made up of many other systems that all must work together.
That's right. A lot of this work's never been done before. We've never had a robot that flies around by itself in microgravity with humans for long periods of time and knows what to do and understands what you say.
What is microgravity?
Microgravity means that you feel very little of the force of gravity because the ISS and everything in it is in free fall as the ISS revolves around the Earth.
Want to learn more about microgravity? Well, then check out the NASA Connect program, Who Added the Micro to Gravity? Now back to the PSA.
PSA has a propulsion system, a sensor system for measuring things like temperature and pressure and detecting obstacles. There's also a navigation system for knowing where it is in the station and knowing how to get from place to place. It also has an artificial intelligence system so it can make decisions, and a communication system so it can communicate with astronauts and ground control.
How will the PSA see where it's going so it can avoid obstacles that may get in its way?
The PSA will use proximity sensors to tell if something is nearby. All these little holes are sensors. We're using sonar or sound waves.
Sonar. Isn't that what bats use to navigate and what whales and dolphins use to locate schools of fish?
Yeah, it's the same idea. PSA also has 4 pairs of cameras for stereo vision.
What is stereo vision?
Well, 2 eyes enable depth perception. With only 1 eye, it's difficult to tell how far away something is. Most animals have 2 eyes. The PSA has 8 cameras, which serve as eyes to perceive depth all around it. The cameras will also be used to show mission control what's happening on the space station and allow video conferencing with the astronauts. The PSA also has a thermal imager that looks for hot spots. This is very important for doing things like looking for an overheating rack. The PSA will also have a laser pointer on it that can be controlled from the ground. Engineers on the ground will be able to point to things on the space station and the astronauts will know what they're referring to.
Wow, the PSA is going to be busy. What other responsibilities will it have?
Well, they can keep track of the astronaut's schedule, alert them when something needs to be done, and give them instructions when they need to repair something.
So the astronauts wouldn't have to use their manuals anymore. The PSA would tell them what to do.
That's right. The manuals are all in electronic form, either in the computers on the ISS or the computers at Mission Control. So the PSA can access the information from the computers and read it to the astronauts or show it to them on the PSA's monitor.
So the PSA is a system that contains other systems so that it can work.
That's right. The PSA has sensor, navigation, propulsion, communication, and artificial intelligence systems.
Thanks, Keith. So guys, what mechanical system did you choose? Now is the time for your teacher to pause the tape so you can discuss your mechanical systems. Here are some examples of mechanical systems you probably come in contact with every day. Dr. Nicewarner mentioned several PSA systems. Now it's time to look in detail at one of those systems.